Let's discuss syllogisms and how we can use Euler diagrams in order to help us make some logical deductions. Right, carrying on our explainer videos here to help us through the UCAT. So first of all, what is a syllogism? You will encounter these in the UCAT as in the logical reasoning or deductive reasoning, and we need to draw conclusions from two premises or two or more. So really it breaks down to there is a major premise, a general statement or universal truth. Then you've got some follow-up ones which relate to it or intersect with it or give some extra clarifications, and then a series of conclusions. And we are going to determine whether or not these conclusions are valid. Do they follow logically from the premises? So a very simple example is all humans are mortal. Socrates is a human, therefore Socrates needs to be mortal. This would be a valid conclusion because by virtue of being human, and we know that all humans are mortal, Socrates is therefore mortal. Okay? Right. Now, here are our important ideas going into this. The real thing that we want to really hammer down is things that are always true or never true. And these are often flip sides of each other. We can sort of think probability wise, right? If I know in probability, go look back at that video. If I know the probability of A, well, I also know the probability of not A because they add up to 1. It's very similar to this. If I know when something is always true, we also know something about when it is not true. Now, keywords to look out for. Never, sometimes, always. These are our key triggers. Now, equally, they are equivalent to none, some, and all. All right, so we know something that about everything, or that is always true, about some things, that is sometimes true, or that is never true, or it is true about no things. These are our three categories that we are looking at. We will also see some if-then statements, but I will talk about them as well, but this is essentially the same as an all statement. We just have to think about it a little bit more, and we'll go into that in a second. We can have either or, right, which is basically a sometimes. Okay? Now, never assume. The only things that are true when we look at the conclusions are things that are explicitly said in the premises or that we can deduce. But never assume. If it's not spoken about, we don't know. And if we don't know, it's possible but not certain. And here's the key. And if a conclusion is not certain, it is false. So when we are looking at like these deductive reasonings, if we don't know 100% that it is true, right, then that's it. You have to be able to say, if you're going to say that something is true, you need to know for certain it's not true. It is true, sorry. And if it is not true, if it is not certain, then we are going to say that this is a false conclusion. It is a false logical conclusion. Right, now we're going to use Euler diagrams. Now, why Euler instead of Venn? If you go back to our video, it just means we are not going to bother drawing every single possibility if we know the possibilities are, if they are impossible. So all A is B. All right. We could also say that as A is always B. All right. These two things mean the same thing. So if we want to draw this as a Euler diagram, we know that the A category is always A is automatically in B. So that is what that would be. I'm going to use lots of different shapes for our Euler diagrams. Doesn't have to be circles, doesn't have to be squares. You can differentiate them the way you want. But this is largely what this means. All of A is B. All right. So if you're in A, everything that is A is in B. All right. Now this is where the if statement can also come in. If A, then B. That means if A is true, then B is automatically true. So these three are the same thing. This is why I said earlier, the if statement is basically an all statement. If A, then B. If A is true, then B is true. A is always B. Now, what we'll notice here is this is not the same thing. You'll notice on my diagram. So what does the diagram help me see? It does help me see that there are some B's that aren't in A. Or there could be some B's not in A. I don't know. If I don't know, I have to assume it is possible. All right, I have to assume it is possible. Now, I don't know for sure there is something in here, right? I don't know for sure, but it is possible until I'm told otherwise. So that is my all statement. Okay, so that's a key one to look out for. None. All right, so no A in B. A is never B. All right, so that's what I mean. No, none, never. Okay, so what does that mean? Well, if we're in A, if we're in the A bubble, it is impossible for us to be in the B bubble. Okay? We could have this as an if statement. If A, then not B. If A is true, then automatically not B is true. Okay? And where we start negating, we can get some interesting things. So if we go back to my all right, there is an interesting thing I can say here. Because I can also say, if not B, then A. So there are implications we can have here. Because we know that A is automatically in B, if you're not in B, if you are somewhere here, look, I'm here, look, that's me right there, looking in, I'm not in B, then, oh, if not B, then, sorry, not A. And remember, we did this in the probability section. We could use little dashes for that as well. Okay, but it means that it's impossible to be in A if you're not also in B. And we can get similar things here as well. All right, but the none just means there will be no overlap. We've got never, we've got none. Now, some. Some A in B. Well, what's that going to be? I'm going to use my two things again. Well, it means that there is some of A that overlaps with B. Okay, so we know for sure there's something in here. Now, point in case, if we know that some A is in B, could there be some A that is not in B? Yes. Do we know for sure there is? No, we don't know for sure. All right. So the important thing here is I don't know if there's anything in there. Maybe. Don't know. But we do know for sure that there is something in there. So we could always color it in. I tend to use ones and zeros. Sorry. All right. So we can use question marks to indicate if we're not sure. Ones to indicate that we are defo sure. And zeros if we know there is absolutely no chance of something being in there. Which hopefully we get correct. But what we could do here, say I misread the question and I hadn't seen that there is no A and B. I could write it this way and then go back and go, well, actually, I know there is nothing in there. Which, interestingly, this is an Euler diagram. This is Venn. In Venn, we have the option of A intersecting B, but it's empty, so I'm going to put a 0. So we're going to have zeros, ones, and question marks. Okay, but this is the idea of some A and B. Anything else is we are going to take multiple versions of these and we are going to put them together. Case in point. All creatures in the realm are either scaled or feathered and are classified as dracons or griffins. Okay, so that's our starting point, is we want to know if things are dracons or griffins, if they're scaled or feathered. Most dracons have silver scales. Okay, so there is definitely some dracons with silver scales. But all other dracons, as well as all of the griffins, have gold feathers. Okay, let's go. What I'm going to do here is I'm going to draw a Dracon box and I'm going to draw a Griffin box. D for Dracon, G for Griffin. Okay, so what do we know? Most Dracons have silver scales, but all other Dracons, as well as all of the Griffins, have gold feathers. So And I do find it a little bit easier with boxes here. So all griffins and all the other dracons have golden feathers. So I'm going to put that there and go golden feathers. And let's do an orange box over here for silver scales. Okay. Now, there's a whole lot of other stuff going on. There might be other animals that have silver scales. There might be some other animals with golden feathers, right? But this is what we know. So let's just double check this tracks with us. Most dracons have silver scales. Cool. All the other dracons have golden feathers. We got that. And all the griffins have golden feathers. Brilliant. Now, a keyword I want to draw your attention to here that is actually highly not useful when we are doing syllogisms is the word most. Okay? It's very difficult to create a solid logical argument with something as vague as most. Like I said in our very first slide, the real ones we want to know about are all or none. Most is not that useful. Okay, so we know we defo have some in here. All right, we could just leave it, or we defo have some in there. Most, we defo have some in there. We defo have some in there. And after that, unclear. But we know we defo have something in all of these. We're told most have silver scales, which means we have at least one. All other ones have golden feathers, so we're good to go. Right, let's use this to answer our questions. All silver dracons have scales. Well, they're either silver or they're golden. The only ones with that are silver have scales, so that will be true. We know that for sure. Any creature with golden feathers, okay, so anything in my purple box must be a griffin. Well, that is automatically not true because there are some dracons with golden feathers, so that is false. Some griffins with scales are colored silver. Well, there are no griffins with scales, so that is false, automatically. All right, some griffins with scales are colored silver. Well, there are none with scales, so that is automatically false. None of the silver creatures have feathers. Right, so if they're silver, they have scales, so that one there is going to be true. And more creatures in the realm have feathers than scales. And again, we've got this word here, more. We have no idea. All right, we have no idea. So that is false. And like, we do know that any creatures in the realm are either scaled or feathers. Okay, and all are classified as dracons or griffins. So I could actually say that there is nothing outside here. In fact, I could have not drawn them in, but it makes the picture like, and the colors a little bit awful. But we do actually know that there are no creatures that are not dracons or griffins. All right, so none of them are out there. So that's how we would approach this question. Let's look at some cooking. All trainees at the Cooking Academy received a gold badge in baking, okay? No trainee at the academy received a silver badge in grilling, okay? So we know that we can do baking, we can do grilling, we can get gold badges, we can get silver badges, probably can get other badges, all right? But we know something about gold badges and silver badges. The professional kitchen only accepts chefs who have a gold badge in grilling, okay? So first things first, we know that everyone in the academy, all right? So we could do two boxes here, right? But everyone in the academy got a baking gold. So I'm going to put that in there. Everyone has a gold badge in baking, so baking gold. Now, no trainee at the academy received a silver badge in grilling. So we know that there are some people doing grilling. Okay. So some of them are doing grilling. G for grilling. GR for grilling. Let's just go grill. There we go. So we don't get it upset with gold. But none of them received a silver badge in grilling. Well, so that tells me you can get a silver badge. I don't know, let's do badges in purple. But none of them did grilling. So don't know why that's there. Okay, so it is possible to get a silver badge in something else, right? You're at the academy, you can do another subject that isn't baking or grilling, but if you got a silver badge of some description, it's automatically not in grilling. So I'm going to represent this way. All right. No, we're back to, we've got our all statement. They're all in there. Everyone does baking and got gold. Okay. But none of them. So we've got this. See how we build these from our 3 simple ideas, and we're building this up. All right. So grilling, you could get a gold badge in. You could, right? The professional kitchen only accepts chefs who have a gold badge in grilling. So in fact, there are some who get a gold in grilling. We do know that now. All right. And in fact, yeah, a gold in grilling. So some do. And we could even, now we got to assume, we could even put it like this if we want. And say you could also get a gold badge in something else. But this gets a little bit tricky because you've got a lot going on, because there's gold with baking and so on and so forth. So I'm just saying, look, let's just say that this is a gold in grilling only. All right. So it's a gold in grilling. So it has to be entirely inside grilling. And then the professional kitchen only accepts chefs who have a gold badge in grilling. Okay. So what have we not used yet? We haven't used green yet. So let's do that. Let's go for green. Okay. So that is my professional kitchen. All right, now bear in mind that the professional kitchen could also accept people that didn't go to this cooking academy. All right, but we are also saying that we are looking at everyone here that went to the academy. All right, the kitchen might accept people that didn't go to the academy, but we know nothing about that, so we're going to ignore it. So Liam trained at the academy, so he's inside my red box, which means he's got a gold in baking. He has joined the professional kitchen, so he's in my green bubble. So he must have received a gold badge in both baking and grilling. Well, he's inside the gold grill, he's inside the gold bake, so that is true. The professional kitchen does not include baking in its menu. That is false. I don't even need to think about it. Why? Because we're talking about the menu. We have no idea. Nothing in this thing tells me about the menu. Do not assume. All right? Do not assume. Just because it says something about, oh, we need a gold badge in grilling, sure. But this tells me nothing about baking. It even doesn't tell me if grilling is on the menu. All right, we know nothing about its menu. Do not assume. Since Ava attended the cooking academy, okay, so we know she's in the big red box. She did not receive a silver badge. Not true. We are saying here, so this is only categorically, we could. We only know that you do not get a silver badge in grilling if you're in the academy. Could be other subjects, could be broiling, could be something else, could be boiling, okay? So this is false. If it said she did not receive a silver badge in grilling, we could have said true, but there we go. No cooking academy trainee can be accepted into the professional kitchen. Well, that's patently false. We've already said that you can. So long as you've got a gold in grilling, you're sorted. Well, you can be accepted. You're not guaranteed. There are some with a gold in grilling that aren't accepted, but we know that you can be accepted in here. Sophie received a silver badge in grilling. Okay, so she did not work at the professional kitchen. Well, to work in the professional kitchen, you need a gold badge in grilling. If you received a silver badge in grilling, you cannot work at the kitchen. So this is true. Okay, we can see that. Now, more to the point, right? What we can also say is she did not go to the cooking academy, because there is impossible to get a silver in grilling at the academy. All right.